My dear students, previous previous video was about the formula of the surface volumes, areas and the volumes. This video will be based on the exercise. That too, I will start the exercise from the question number 2. The question is like this. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. So what the basically question says? Question says this. We have a vessel. Vessel means that we can put something into it. Vessel is shaped like this. You have a hemisphere at the bottom and you have a what? Cylinder mounted on it. That it is simple thing that it contains two objects. One is hemisphere and second is what? It is a cylinder. Both are hollow. That's why we call this as what? Vessel. This is height. This is denoted by the h and this is the height of cylinder. This will be definitely simple. This is the r and radius of what? Hemisphere. Here from this point to this point it is again the r because the question says so. The radius of the hemisphere and the radius of the cylinder is same. So what we will write? Since radius of what? Hemisphere is equal to radius of cylinder. That too is equivalent to how much? It is 14. Diameter is 14, so simply radius will be equivalent to 7 centimeter. Right? Also, total height of the vessel is given. Total height. That means if I put capital H here, capital H, so H is given. Total height of the vessel is given. That is height of vessel. From the figure it's clear. It is equivalent to height of cylinder plus its what? This is a radius. It will be radius plus radius of hemisphere. Radius of hemisphere. Radius of hemisphere I know that's equivalent to 7 centimeter. Total height I know it's given, that's the capital H. So what I can do? I will put the what values here and I will get the height of the cylinder. Height of the vessel, it's given. It's equivalent to 13 centimeter. Right? That means 13 is equal to height of cylinder, that is denoted by the small h, plus r. R is here, it is 7. Right? Or I can write small h is equal to 13 minus 7, that's equal to 6 centimeter. So I can conclude here the height of the cylinder is equal to 6 centimeter. The radius of the hemisphere and the radius of the cylinder is equal to 7 centimeter, right? And the total height of the vessel is equal to 13 centimeter. Now the question is what we are supposed to find. We are supposed to find the inner surface area of the vessel. Simply, this is cylinder. Let me show you like this. We can imagine the thing here. We have a cylinder. This is a cylinder. This is a top circle. This is a bottom circle. And we have attached a semicircle into it. But this is hollow, completely hollow. So we can put a liquid into it. Right? But if I put my hand inside the what? Vessel. I can touch the vessel like this. It is a what? Curved surface area. Then I can touch the vessel in the hemisphere. So there is a curved surface area what? Of hemisphere plus the curved surface area what? It is a cylinder. You don't have the circle. So we can't add the circle there. Right? So what will be the formula? It is simple. So I can write here inner surface area of vessel is equal to the inner surface of a cylinder plus inner surface area of what? Hemisphere. That's equivalent to 2 pi r square. Clear? It's for what? It's for the hemisphere. We know these formulas. Plus 2 pi RH. And 2 pi RH is for cylinder. But here you don't have the capital H, you have the small h. And that we know, that's here. That's 6 centimeter. What we will do? We will just make it simple here. Here you have the 2 pi here, r here, r here. We will just do one thing. 2 pi r will be our common term. Then here you have the r and you have here h. 2 we will put values now. 2 you have here and 22 by 7 the value of h, because in exercise there is written you use the value of what? Pi equivalent to 22 by 7. Then you have the r. What is the value of r? R is equivalent to 7. Then we have the here in this bracket 7 plus 6. This 7 and this 7, simple mathematics. 7 and 7 cancels. Then I can write here 2 into 22, simple 44. Then multiplied by 8, 7, 8, 6. 6 plus 6, 12, it's 30. So simply we can do this. So the value is equal to 572. 572, but what is this? Is the surface area. So the unit will be centimeter square. This is the answer of this question. So what physically it mean? Physically it mean the total inner surface area of the vessel, which includes what? Cylinder plus hemisphere. This is equivalent to the 572 centimeter square. This is all about this question number 2. Let us now move to the next question, which is question number 3. Question 3. I will read the question here. Question says a toy is in the form of cone. So I have a figure here, cone. Cone is like this. This is cone. So we know this cone is having how many dimensions? One is it's a perpendicular height. This we denote as a small h. We all know this. Then it is the apex point here. We denote it by O. Then we have a slant height. We denote by L. Then we have a radius. And simple, we denote radius by small r. Small r. Clear? Let us move to read the question furthermore. A toy is in the form of cone of radius 3.5 centimeter. It's given. Since radius of cone, it's given 3.5 centimeter. Okay. Then mounted on a hemisphere. This is mounted. This is not mounted by. This is mounted on a hemisphere. So figure will be like this. It is mounted on a hemisphere. So condition is simple. If this is mounted on a hemisphere, there are two chances. Either the R should be same or R should be different. If it is same, then definitely this cone will be these points, end points will definitely touch the end points of a hemisphere. If there is a change in dimension, either the cone will be bigger, the circle of the cone will be bigger, or it will be smaller than what? The circle of a hemisphere. But here the question is simple. The radius of hemisphere and the radius of cone are equal. They are same. That means R for the hemisphere and R for the cone is same. That is equivalent to what? 3.5 centimeter. Then the total height of toy is 15.5 centimeter. The total height, which starts from here and it will come till this point. I will write this, I will denote this by capital H. It is given equivalent to how much? 15.5 centimeter. This is 15.5 centimeter. And I know from this point to this point, we have the small h, that's the height of cone. And then from this point to this point, we have a R, Because this is hemisphere, it will be r here from this point to this point, and from this to this it will be again r. Clear? Let's move on. Total height of this equal to 15.5 centimeter, and we can calculate the height of what? Height of cone. Simply, we will write here, therefore, height of cone will be equal to total height. That's the height of toy minus what? Radius of hemisphere. Radius of hemisphere. Clear? Height of toy, it's given, it's equivalent to 15.5 centimeter. Minus radius of hemisphere, how much? R. R is given also, it's 3.5 centimeter. Clear? So 15.5 minus 3.5, it is simple, it is 12 centimeter. Therefore, the small h, that's the height of cone, is equal to 12 centimeter. Furthermore, we will calculate now this L, that's the slant height. We know this. What we know? L square, we will write here, we know that L square is equal to R square plus H square. Simple. We did this in previous video, which implies L is under root of R square plus H square. The value of R, we know. The value of H, we know. So just substitute the value. That's R 3.5 whole square plus H. What is H? 12. 12 square. 3.5 whole square. What is the value of that? It's 12.25. 12.25. 12, it's 144. It's, just add them. What is the value? 12.25 plus 144. It becomes equivalent to 156.25. 156.25. And do the square root of this number. We will get 12.5 centimeter. 12.5 centimeter. So, I got the value of this L, which is slant height, right? From 0 O to this point is L. We got the value of L is equal to 12.5 what? Centimeter. I will write now here because I have to rub the board. H I got 12 centimeter, right? L we got 12.5 centimeter. Rest I will. So what we are supposed to find? We are supposed to find the total surface area. Total surface area. Therefore, total surface area of toy will be equivalent to surface area of cone. Surface area of cone, it will be basically the curved surface area cone, because on the base we don't have the area, you can't touch it, right? There is a hemisphere attached to it, so it's a curved surface area of what? Cone. Curved surface area cone. Plus again it's a curved surface area of hemisphere. Curved surface area C dot S dot A of hemisphere. And we know the formulas. We have read that. What is the curved surface area of the cone? That's a pi RL. What is the formula for the hemisphere? We know that. That is equivalent to 2 pi r square. 2 pi r square. So again, we will make it simple. How can we make it very simple? We can just put pi and r common, and L will be here, it will be r. Clear? So just put the value now. It will be pi r L. Here you have the pi r and it will be 2r, not only r, it will be 2r, 2r plus L. So just 22 by 7 and r is 3.5 and L you have equivalent 12.5. We got that 12.5, it's 12.5 plus 2r. 2 is here, what is the value of r? R is 3.5. So do the simple mathematics. So here have the 3.5, you have the 7. So I have done this 22 by 7 into 3.5. I will just simplify it. 2 into 3.5 plus 12.5. That gives me equal to 19.5. 19.5. Clear? And I will do this, multiply 22 into 3.5 into 19.5 whole divided by 7. That value is equal to 214.5. 214.5 centimeters square. This is the answer of this question. But what physically it means? It means that the area, suppose you will touch this toy, how much area you can touch it? That area is equivalent to 214.5 centimeters square. You can't touch the base. You can't touch the circle of a hemisphere. So that will not include in this. Which part you can touch? We can touch the bottom of the hemisphere. We can touch the curved surface of what? Cone. So the total surface area is definitely equivalent to pi RL plus 2 pi R square, and we got the value equivalent to 214.5 centimeter square. So this is the answer of this question number 3. Right? So let us move on to the next question, which is question number 4. This question is an interesting question. Question number 4 is very interesting. Question says, a hemispherical depression. There is an object in this question. It is a what? Cube. It can be anything. But in the cube, we are getting what? We are making a depression. We are making a depression. Depression means we are making another figure into it. But some specified shape. The shape is what? It is a what? It is a hemisphere. The question says the hemispherical depression is cut out from one face of the cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. So question is like this. I have a cube here. This is cube. I am making the cube 3D object on 2D. This is cube, right? On the top surface, I am just depressing. I am making a hemisphere. So how can I make it? I will make it by black. I am just what? Excavating a material from top surface, and that's equivalent to, this is L, it's given, this is given, this is given, this is a L, right? So L, therefore this L is equal to diameter of hemispherical depression. Hemispherical what? This shape which is depression into it. Depression. Right? So we can write like this. Since diameter of hemispherical depression, that's equal to the length of what? Or you can say edge of what? Cube. Therefore, D is equal to L, or I can write R is equal to what? L by 2. I can write the R is equivalent to L by 2. It's simple. Diameter is equal to L. That means R is equal to L by 2. That's a D by 2, and D is equivalent to L. That's a L by 2. It is simple. That means you have the center here. This is R and total is L. Simply that R will be equivalent to total divided by 2. L by 2. Simple. So R is equal to L by 2. I will put this in a box. Now the question says, such the diameter of the L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. That means I have to what? Find the surface area. That means this area, it will be there. This side, it will be there. Bottom, it will be there. Behind side, it will be there. Front side, it will be there. But what happened to the top side? It is not a plane surface now. It is now a hemisphere. So hemisphere, when I touch the body, it will go like this. So the total surface area will be equivalent to the surface area, total surface area of a cube, right? Plus the curved surface area of a hemisphere, but it will definitely minus by the one side, because the one side is not there. Now we have the hemispherical surface area. So I will write surface area of remaining solid after doing the depression on the top surface, right? That will be equal to total surface area of cube, TSA, T total surface area of cube, plus inner surface area of hemisphere, because I can touch that hemisphere, inner surface area of hemisphere. But the question is, the total surface area of the cube, it's equal to what? It is 6a square. A square and 6 sides, that means 6a square. But what happened to the top surface? It's not given there. It's not now there. So what? Definitely I have to minus, that's a what? Area of the base hemisphere. Minus area of the base hemisphere, because you don't have the circle there, right? But you can have the edge, small edge at the 4 corners there. Total surface area of the cube. Total surface area of the cube is 6a square, but A it's equal to L. So simply it's a 6L square. It's a 6L square plus inner surface area of hemisphere. We know this, that's equal to 2 pi r. 2 pi r square. 2 pi r square. And what? We have to minus it the area of base circle. Base means it's a circle. Minus pi r square. Simple. 6L square plus 2 pi r square minus pi r square. It's simply pi r square. So 6L square plus pi and r. R is equal to, it's equal to L by 2. That means L square divided by 4. Simple. It's a 6L square plus pi L square divided by 4. So we can simplify it more. It will become 6 4 r 24 L square plus pi L square divided by what? Divided by 4, right? And then I can do one thing. You have the L square here, you have the L square here. You have the L square divided by 4 and 24 plus pi. This is the answer, that is L square plus by 4 into 24 plus pi what? Square. We have the centimeter. What we have the unit? We don't have any unit. L, we don't have any unit. So we can say square units. We don't know what is the L. Either it be in centimeters, millimeters, meters, but how much I don't know. So simply the answer is this. If we put the value of L here, I know that then what? I will put the value of L here and I can simply solve this problem and I get the numeric value. But L is known what? Known to us. Therefore the answer is this. L square by 4 into 24 plus pi square units. Right? So we will conclude this topic here. Right? So inshallah in the next lecture, in the next video, we will take the next question and we will start inshallah from there. Thanks a lot.